Okay, so we're going to go through how to solve problems involving linear relations. So example 1, Sonia is a piano teacher. She earns $35 per hour. Sonia wants to earn $200 each day. There are two ways to determine the time she needs to work to earn $200. The first one is to create a graph. So how much does she earn for 0 hours taught? Well, she earns on the hour and she doesn't get money otherwise, so that means that this is a direct variation. And she was gonna earn, she earns $0 for 0 hours taught. Let's graph the situation. So here we have how much she works, so time, and it's in hours. And here we have amount earned. So at $0, she earns $0. At 1 hour, she earns $35. And it's going to keep going up by $35 because it's $35 per hour. So I'm going to go by 35. So that's 35. That's 70. I'm just going to skip every other one. So that's 140. And that's 210. 2. And then I have 350. No, sorry. 210. Then I have 280. And 2 more. 350. Going up by 35, but I'm labeling every other one. So I'm adding 70. Okay, so every hour she works, she makes 35. So 1 hour, 35. 2 hours, she's at 70. 3 hours, another 35. 4 hours, another 35. 5 hours, another 35. 6 hours, another 35. 7 hours, another 35. 8 hours, another 35. And 9 hours, another 35. So here we have a nice straight line. Okay. So the question says, how much will she earn for 200 hours? So 200 hours, approximately here. It's below this line. Follow it all the way down. So we have to approximate from our graph, and we can say it's from the graph it's approximately she has to work. In the graph she has to work. So if you look here, it's like between 5 and 6, so it's more than 5.5 hours. So we can say 5 hours and 45 minutes. So she has to work approximately 5 hours and 45 minutes. Okay. How much does she earn for 9 hours taught? So now we're going to look at 9 hours and approximate there. Okay, just go across. So this is going to be 3 hours and 15 minutes. So 280 plus 35 is 3 hours and 15 minutes. That one we can be certain about. Oh. There's two definitions here. One is, I'm going to fill in extrapolation. And that's basically where you have to extend your graph beyond data to make guesses. So we use extrapolation when we need to extend the graph to determine a value that is outside the given data range. And then we use interpolation when we determine a value that is within the given data range. Okay, so we don't always want to have to draw a graph. So sometimes you want to create an equation and solve the equation using the solving skills that you would have learned previously. So there's two variables. We know that one is our dependent, so it's the amount she earns, and one is the time in hours. Minutes here. So I'm going to define variables for that. Amount earned. That's our dependent. I'm going to let that represent y. And I'm going to let x represent the hours worked. Okay. So y is equal to, since it's direct variation, you put the slope here, so it's $35 an hour, and then you times it times the number of hours. There's no fixed cost, there's no fixed amount, so there's no plus or minus anything. To solve this, I want to know exactly how much she needs to work for 200 hours. Well, that's $200. That's my y. So I plug that in there. Now I'm left with only one variable, and that's x. So now we know from previously, to get x by itself, we would divide both sides by that number. So we divide both sides by 35. And then x is equal to approximately 5.71. So we were close. Okay. So she needs to work, so Sonia needs to work 5.71 hours to get $200. Okay, so let's look at the next answer. The next question, sorry. A candle is 13 centimeters long. It is lit and burns at a rate of 0.2 centimeters per minute. So remember, rates are our slopes. And this is how much it started with. So write an equation for height, and they're defining them for us. H is centimeters, after the candle, after time, T in minutes. So H is height in centimeters, and C, sorry, not C, they told us it's T is time in minutes. So let's think. This one is not direct variation, it's partial because we start with 13 centimeters. So our height starts at 13 and it's going to burn. So that means the rate is going down. So we're going to subtract 0.2 centimeters. It's 0.2 T. And now we're going to learn how to go through solving. So how long does it take the candle lit? Until the candle is 10 centimeters. Well, let's plug in the 10. That's our heights. So remember our formula from before. You only want one variable when you're solving. So height is 10. 7 these variables. Then we want to isolate the variables. So I want to get rid of this 13 beside the t. So remember, subtract 13 from both sides. That becomes 0. So I'm left with 10 minus 13 equals to 0.2 t. 10 minus 13 is negative 2. And then divide both sides by negative 0.2. So t is equal to 15. So therefore, it will take 15 minutes for the candle to be 10 centimeters. Okay, we're going to do another example. Rob sells advertising. He earns a basic wage of $75 plus commission. Robert earned $175 when he sold 1,000 worth of advertising, and he earned $575 when he sold $5,000 worth of advertising. How much will he earn if he sells $6,000 worth of advertising? So it says create an equation to solve. So first, I'm going to graph these just to visualize this. So he makes money based on how much advertising he sold. So amount sold advertising is our independent. And the amount earned is our dependent. Okay. So what happens is he brings the basic wage plus commission. So we only know 2 points, and that is that when he sells 1,000 worth of advertising, he makes 175. So it's approximately here. And that when he sells 5,000 worth of advertising, he makes 575. That's around here. 5. Okay, so that means that my line is a little off because they also told us that he starts at $75 right here. Whoops. That's his starting wage. So he actually makes $75 just for soloing nothing. Okay. So it says to create an equation to solve. So let's create an equation and then we'll see. Well, for an equation, I need my slope. Okay. So I would need to find my rise and my run. And our rise comes from these points. So our rise comes from the 575 that we graphed, subtract the 175. And our run comes from here. So 5,000 minus 1,000. So our slope is equal to rise over run, which is equal to 575 minus 175 over 5,000 minus 1,000. So we have 400 over 4,000. So our slope is equal to 0.1. Remember our equation, so let's make up some variables. So amount earned can be E and the amount of advertising sold. Let's use N. So let's see. In order to make money, he starts off with $75 and then he gets 0.1 for every dollar he actually sells. So there's our equation. Remember, this is partial variation. So now we have an equation we can actually solve for how much you would need to sell in order to make $1,000. So we put 1,000 here. That's our earning. It's 75 here. Plus 0.1n. Okay. Then we would subtract 75 from both sides to get n by itself. So that will become 925.1n. Then we divide both sides by 0.1 to isolate n. So n is equal to 9250. So Robert would have to sell $9,250 worth of advertising to make $1,000. Alright, that's it for this lesson.